Hello, my name is Jan, and the supplement I have chosen to do my presentation on is glutamine. So without any further ado, we can get right into it. So glutamine, what is it and why should I care? So what is glutamine? Glutamine is a non-essential amino acid that plays multiple different roles in our physiology. It is the most abundant amino acid in our bloodstream, and over 61% of our skeletal muscles is made up of glutamine. It is also the preferred respiratory fuel for lymphocytes, which are white blood cells, hepatocytes, and then our intestinal mucosal cells. It also plays a big role in transporting nitrogen throughout our body. So our body gets glutamine in two different methods. So there is the internal and then the external method. So the external method would be our diet. So food like chicken, fish, steak, eggs, uh, milk, cheese, yogurt, all these foods contain high levels of glutamine in there. There's also vegetables like red cabbage, parsley, spinach. These also contain high levels of glutamine in there. Then there's also glutamine comes in powder and pill form. But with this, you have to remember that you take it with cold or room temperature water, because the heat in warm water will start to denature the glutamine protein and it'll render it useless. And with these, it really depends on what your lifestyle is like. But the younger population tends to veer more towards the powder versus the older generation takes of the tends to go with the pills more often. Um, so yeah, here's just a breakdown of that. And one other thing you have to remember is that glutamine from animal sources tend to provide more digestible glutamine than from through plant-based sources. The second method or the next method that your body gets glutamine through is the internal method. This is done by a enzyme called glutamine synthase, and this can be found in the skeletal muscles, the brain, and the kidneys. And glutamine synthase, essentially what it does is it catalyzes the condensation of glutamic acid and ammonia together to form glutamine. And under any normal circumstances, this function or this method can generate enough glutamine for your body to function normally. One of the biggest functions of glutamine in our body is for protein building. So glutamine promotes the growth of muscle, and then it prevents the degeneration of muscle by preserving an amino acid called leucine. If you go here, you can see this is a diagram of protein synthesis, and these cross-like structures at the top here are called tRNA or transport RNA, and these have amino acids attached to the top of them. One of them is being leucine, and this amino acid right here is what's responsible for transcripting for muscle cells. Another function glutamine has in our body is the immune system function. So glutamine is used as a fuel source for white blood cells, which is used to fight off sickness and inflammation. And in times of injury and sickness, your glutamine levels drop significantly. And this is why it is important to get glutamine through external sources during these times, so your body has enough fuel to fight off the sickness and injury. The final method we're going to take a look at is the intestinal health and the role that glutamine plays in it. So if you want to imagine our intestinal or gastrointestinal wall as a mesh strainer, you can see here at the top the mucosa, and these little channels, they're called tight junctions. And what they do is they filter out bad toxins and bacteria and lets in nutrients like fatty acids, vitamins, minerals, all that stuff into our bloodstream. There are some cases where these channels, these tight junctions, let in toxins and bacteria into our bloodstream, and this condition is called leaky gut. And if you leave it untreated, this can cause an immune response, resulting in inflammation, and this can turn into a much more serious health problem. And what glutamine does is to the mucosa, which helps regulate the cell wall, is it helps repair and regrow these damaged areas so it can filter out all the bad all the bad bacteria and the toxins out and just strictly let in all the nutrients. So who should be taking this? Mainly we like to see athletes taking them just because the lifestyle they live is a very physically demanding one. Their body is in a constant state of stress, and in order to help recover from the stress they put on their body, glutamine can be used to kind of catalyze that recovery time. Many individuals also who suffer from sickness and muscle wasting diseases, like many cancer patients, they tend to lose a lot of body weight because of the treatment. And this is why glutamine is very helpful for them, because it will help preserve their muscle mass and help them retain a little bit of weight as they go through the treatment. There's also individuals who suffer from any kind of digestive issues like irritable bowel syndrome can also benefit from supplementing from glutamine, as it will help protect the gastrointestinal lining and help filter out any bad toxins and bacteria. So dosage and amount. Usually, it really depends on what the reason you are taking glutamine, but a normal adult can take between 5 to 45 grams of glutamine without seeing any negative side effects. And researchers show that we get around 3 to 6 grams through our daily diet, and because of this, the glutamine intake or the effects of glutamine, high glutamine intakes is currently not very researched. So it is typically recommended that you stick to the dosage amount recommended by the manufacturer. There are some side effects for taking a high level of glutamine. Even though it is made in our body, it is too much of anything can be a hazard. In high intake, there has been cases where people have seen blood in urine, change in skin color, lower back pain, irregular heartbeats, dizziness, and rash. It can also change how your body distributes amino acids throughout itself. However, the long-term impact of this is currently unknown because it is not very researched. It can also make existing conditions of the liver and kidney even worse because, proteins are filtered through there. So the first case study I was looking at is a research study conducted by Dr. Yoshida and his team in the year 2000, where they looked at supplementing chemotherapy patients with glutamine. So they started off by actually giving two groups of mice that carried tumors glutamine. So one group got glutamine and then the other group didn't, and they saw that in these mice that the group that got glutamine actually ended up holding on to more weight. They ate a lot more food, and they tended to live a little bit longer than the mice that didn't get the glutamine supplementation. And they eventually moved on to doing this with humans, and they saw that their immune system, it boosted their immune system, and then it helped them keep down more food and just live a healthier lifestyle as they were going through chemo treatment. The next case study we're going to look at is a study conducted to reclassify glutamine as a conditionally essential amino acid. So normally, glutamine is considered a non-essential amino acid just because your body makes enough of it by itself. So you don't typically have to get it through your diet. But there are certain times, like when you're sick or you're injured, where your body will outstrip its supply of glutamine and you'll be in a glutamine deficit. So this is why in these times, you need to get glutamine through your diet. That is why they wanted to reclassify it as a conditionally essential amino acid, because there are certain times where it is essential to get it through your diet. Yeah, and again, these times occur mainly when your body is experiencing excessive stress, like through or through sickness or injury. So these are my citations for the project, and thank you very much and have a good day.